All right, welcome back, everybody. Today, we're going to be talking about section 3.3, day 2. Our objective today is that you will be able to condense logarithmic functions using the properties of logarithms. So yesterday we were talking about how we expand and make stuff bigger. Today we're going to be talking about how we take expanded stuff and put it back together. So before we do, let's just review condensing a little bit. So again, these are the properties that we are going to use. Remember that if we multiply, we really add. If we divide, we subtract. And then if we have a power, that power gets pulled down in front and multiplied. It says, note, unless representing a quantity, get rid of the parentheses before condensing. So let's try to work backwards here. So looking at this first problem, here we see that we have two things that have the same base. That's going to be something that we're going to need to see in order for stuff to be condensed. But we're not going to try to mess with you. I think every problem will have that. Here we do see that we are subtracting, which means we divide. The first one always goes on top. The one that has the minus in front is going to go on the bottom. So I could rewrite this as the log base 5 of 6 over x. Right? We're just taking it and reversing kind of what we practiced yesterday. Looking at the next one here, both of these are log base 10. We do see that this one has a power in front, so the power, we're going to put it back up here. So this will now be a 1/2 up here, and I can basically kind of scribble that out. Again, we do see that we are being subtracted, which means division. So we're going to have log base 10 of 5. That's going to be the one on top. Then we have the minus, so now we're indicating we're on the bottom. X to the 1/2. Now, one thing we can do to make this a little bit nicer is that x to the 1/2 can be written as just the square root of x. So we could really rewrite this as 5 over the square root of x, like so. Looking at the last one. Now, this 1/2, as we see, is actually going to go to both of these at the same time. Or it belongs to both. So we can actually put this together to start if we want to go this route with it. So we would have log base 4. Now these are being added, so they're just being multiplied of a, b with the 1/2 in front. Now the 1/2 does need to move back up top. Since it belongs to both of them, we can put parentheses around this and put it up there. So then we would get log base 4 of a, b with the 1/2 up top. And the 1/2 of top just means take the square root of it. So this is really the square root of AB. Now, that's one way to arrive at that answer. You could have also went at it a different approach, distributed this to each of these to start. If you went at it that way, you would have 1/2 log base 4 of A plus 1/2 log base 4 of B. And to deal with this, you would have moved this 1/2 up top right away. So you would have gotten log base 4 of a to the 1/2 plus log base 4 of b to the 1/2. Then you would have seen, hey, they have the same base, so we can put them together. So you would have had log base 4 of a to the 1/2 times b to the 1/2. And then since you realize they have the same power, you could rewrite it as a times b, both to the 1/2 power, and then head on over to the square root representation. So two ways to get to the same answer here. Over here, we're being asked to condense yet again. So coming over here, these two things are both log base 10. If we don't see it, we don't need to write the 10, but we just need to realize it. Since we are subtracting here, what we want to do is divide. So this is going to be log of 6x over 6. Remember, this just gets treated like a fraction at this point, so those two 6's can actually cancel and reduce out. So I would just be left with the log of x. Looking at this next one, this one gets a little bit more intense right now. So first off, I see this coefficient in front. That's going to have to move up top as an exponent here. Nothing else has it. They are all log base 3. The way I like to think about it, actually, so hold on. I think this log base c over here for this last one. I feel like this is a typo over here. So we're going to make this into log base 3 because it really doesn't make sense for our purposes to be changing bases on you. So when we come over here, if that's log base 3 and not a c, then when I come over here, since these are all log base 3, we can start putting them together. If they have a plus in front, they're going to end up on top. If they have a minus in front, they're going to end up on the bottom. So I'm going to end up with log, let me write it over here, log base 3 of 2, that's just positive here, so that's going to go up on top. And then it's plus x, so times x. So done. Then the 2 has moved up here, so now this is like an exponent, y to the second, but it's positive, so it's going to be a y to the second up top here. This one has been talked about, and now this one's finally the minus, so we are going to be dividing by z to the 3rd power over here, which will make this our final answer. Looking at the next one, a little bit more, a little bit easier to look at, I think. So first thing I notice is that we're just adding over here. These are both log base 2. There's no coefficients or exponents to consider here, so we're good. So we're going to come over here, log base 2. The positive one will go on top. Actually, they're both positive, right? So since it's a plus, they're just multiplying. So this is 4 times the square root of 8. Now, officially, you could probably make this a little bit nicer by simplifying the square root of 8, because 8, of course, is 2 and 4, which is 2 and 2. So I can pull out a pair of 2's, which will make this into 2 times 4, gives us 8 square roots of 2. And that's just part of going through and simplifying as much as possible. So log base 2 of 8 roots of 2. This last one's maybe the most unique because this one introduces the ln. Now the ln really is just the natural log of a number. That's what ln stands for, is natural log. This gets treated very much the same as a logarithm does. So instead of saying the natural log, so what the ln really is, and we'll get to it here in a second, is the natural log is just log base e of x. So instead of writing that, we just actually keep it with ln. It's a way of shortening this up a little bit. We'll show you what that looks like here to work with. So again, since these are both ln's, we can combine them in the same manner. Since we do have a plus here, we do want to just multiply. Now, one thing to notice is that this 5 in front, that's really an exponent to this x. So this is really x to the 5th, and we can get rid of this. So rewriting this, I will have the natural log of x minus 2. Now, that's a quantity, so we can't quite just get rid of that. I'm going to put brackets kind of around this whole thing. And then that's times x to the 5th. So if we go a little bit further with that, inside we definitely could simplify some. So distributing this x to the 5th to each of those, this would be the natural log of x to the 6th minus 2x to the 5th. That is probably how I would say you get your best answer for this one to condense. Let's talk a little bit more about the natural log here. So what is the natural log of x? The ln, again, this means natural log is how this gets read, is when we are taking the log base e, right? That's Euler's number right there. So whenever we're taking log base e, it gets denoted the natural log. It really works very much the same way. So coming over here, here's how I would approach it. I would first start by distributing this 2 into everything. So I would get 2 ln of x minus 6 ln of y plus 2 ln of z. Any coefficient is really an exponent, so this 2 is going to move back up, the 6 is going to move up, and the 2 is going to move up. So I'll get the natural log of x to the 2nd minus the natural log of y to the 6th plus the natural log of z to the 2nd. Now remember, the way this works is that if it has a positive in front, it goes on top. If it has a negative in front, it goes on the bottom. So positive here, so this is going to be the natural log of x squared is going to go on top. Then on the bottom, I'm going to get that y to the 6th because it had a minus in front. And then this one had a plus in front, so that's going to end up on top. So this would be z to the 2nd power. So this would be our condensed form of that, the natural log of that. Looking at a few more problems here. So we have a couple more condensed problems. So again, if it has a coefficient, move it into the exponent and then get rid of it. If it has a coefficient, move it into the exponent and get rid of it. Once you do that, Then we want to rewrite. Now remember, this is positive right here, so this would be the log, right? We're assuming it's base 10 since we don't see a base. But we don't need to write it, of x to the 1/2. Now since we have subtraction, the y is going to go on the bottom, and subtraction, the z to the 3rd is going to go on the bottom. The last thing we can do to rewrite this is to simplify x to the 1/2. That can of course be written as the square root of x. So I'll have y z to the 3rd here. Looking at the problem below, again, start with your coefficients. This 2, move it up top, scribble it out. The 3, move it up top, scribble it out. The 1/2, move it up top, scribble it out. The 1/2, move it up top, scribble it out. Once you've gotten that far, then it's time to rewrite. This is positive, so that's going to go on the top. So this will be log of a to the 2nd power on top. And then I'm going to get, since it's a b or a minus, that's going to go on the bottom now, b to the 3rd. A minus, this is going to become c to the 1/2. And a minus is going to become d to the 1/2. Now when I rewrite these, anything to the 1/2 can be just written as the square root. So this would be the square root of c, and this would be the square root of d. Since they're both square roots, these actually can be combined to be the square root of cd, making my final answer into the log of a squared over b to the 3rd square roots of cd. Right? A lot of simplifying going on in that problem. Last one we're going to look at right here. Again, this 1/2 is on the outside. You could go about it 2 ways. You could distribute it in now, or you could deal with it later. I think I'm going to distribute it in now, just because I haven't done that in a while, I guess. So I would have the 1/2 of log of x minus 2 log of y, right? Because half of 4 is 2. Exponents move up top. So I'm going to get the log of x to the 1/2 minus the log of y squared. So when I combine these, since they have the same log, we're going to have the log of x to the 1/2, which will be the square root of x on top, since that was the positive one. And then since it's minus, this goes on the bottom, so y squared down here, making this our final answer. Now the last piece of this is actually going to go back to something we were doing yesterday. So yesterday, in one of the very last problems we were simplifying, we got to this expression here, log base 2 of 100, and we actually tried to evaluate it. And what we said is that there was no nice number x that made that work. That's because 2 can't be raised to a power of 100 using just a kind of a natural number, right? Now, to deal with that, mathematicians found this change of base formula. And the way the change of base formula works is the change of base is used so that you can calculate any base in the calculator using base 10 or base e. Be sure to end the parentheses on top. Okay, so this is what we're saying. It's if I have the log base b of m, I can say that this is exactly equal to the log of m, right? So the log of the big number divided by the log of the base. And that will evaluate the exponent that would have made that true. This is much easier to look at when you actually look at a real number. So thinking about this, right? These are both numbers. If I rewrote this as an exponent, I would have said 5 to the x is equal to 7. Now, 5 to some power equals 7. We don't know what that power is. Here's how we find that power. We take a look at the log of the big number, 7, and we divide that by the log of the little number, 5. And when you punch that in, you actually get this number right here, 1.2091. And what that number is that number is really x. So the x value. So if I take 5 and I raise it, to the 1.2, here we go, so 5 to that power of 1.2091, I actually get 7, basically, right? So we rounded that off a little bit, but that's where you see 7 come out. So 5 to that power gives me 7. That's what makes these logarithms kind of so powerful for us to be working with. Now, when realizing that, it's like, okay, well, how do I actually get that number? And this is how you punch that in. You can punch this in on your calculator using the key right here. So I know it's kind of hard to see. I'm switching kind of between two apps. But right next to the 7 on your graphing calculator, you should see your log button. So you can type in log of 7. Now you got to close that parenthesis to make sure this works. Divided by the log of 5. And again, I always close those parentheses, and that's where I get that number. Now, you can see our number, 1.2091, has actually been rounded and chopped off. If you actually take this a little bit more specifically, so 5 to that power, and just grab that number, you'll actually get a number even closer to 7 than what you previously had, because a little bit of a change makes a big difference here. Now, it is really important to realize that looking at this, so log of 7 divided by the log of 5, we get that number. That's the same thing as if we look at the natural log. So looking at the option below, the natural log here would be the natural log of 7 divided by the natural log of 5. We get the same exact answer. So those two actually can be used interchangeably. So let's talk about how these get used here. So it says, use common logarithms to evaluate this. We know there's no power that's going to raise 2 to the 2 and set it equal to 9. So the way we're going to solve this is we're going to look at logs. So we're going to say, okay, well, to get the answer to this, it would just be the log of 9 divided by the log of 2. And when I do that, log of 9, close your parenthesis, divided by the log of 2, close your parenthesis, is equal to 3.1699, let's just call it. Now, what that means is that if you were to take 2 to that power, 3.1699, you should be equal to 9. So let's check that out real quick. 2 to the 3.1699. Look at that. We are virtually equal to 9 right there, ladies and gentlemen, which means we did our problem correctly. Looking at one more, this one has a natural log here. So again, same numbers. We would just take the natural log of 9 divided by the natural log of 2. Natural log of 9. Nope, we gotta close those parentheses. Divided by the natural log of 2. Notice how we get the exact same number here. So what that means is that if I take 2 to the x power, that should be equal to 9, and x is really equal to this, which should check out because it worked up above just the same, right? So that's how we deal with things that can't be evaluated normally with just a nice number as that exponent. And sometimes we're going to get ugly exponents, and this is how we're going to work with them. Thank you guys so much for watching this full video. If you have any questions, please don't hesitate to reach out. Have a great day.